Now let's go to the slides here and do the description for case 2. Now, this one's going to be interesting, very detailed, right? And we actually had this one as case 1, but we figured, all right, let's not make the first case the beast, right? So this is the case we have, right? A customer concentration at the end of a long radial distribution feeder, let's call it Detroit 1201, is having a high number and duration of outages per year. Load in the affected area is about 50% of the feeder head load, right, measured at the substation. So here, consider this is a substation, right? The load concentration here, we're saying that's 50% of the load on the feeder, okay? We have recorded outage events from several years, so we know kind of at a high level how often and how long outages are, rather. Right? Now, secondary application, right? The substation transformer of this feeder, Detroit 1201, has the following characteristics. The bank transformer ONF capacity is 2 MVA, right? Even though I know probably Duke Energy doesn't have any 2 MVA bank transformers, right? So, all right. Peak load expected to reach 3 MVA in 10 years. So we're assuming, and we're also assuming a 3% yearly load growth, right? Load peak occurs seasonally. Upgrading the transformer bank requires a substation expansion and will cost $13 million, right? If for any of you that haven't noticed, this is based on a real story, kind of as the movies are, based on a real story. So this is actually a case for a battery project that is now in operation. All right, so we start off with sizing the primary application or designing the primary application, right? So just to give you an overview of the input profiles here, right? So the expected BESS load for the reliability application, we expect that to be the feeder load today, right, times the expected load growth divided by 2, basically, to represent 50% of customer load within the load concentration, right? But we're not expecting that all year, right? We're expecting it only during outage events, right? Which, we said we know the duration and kind of frequency of occurrence. So we come here to Sterlytics, right? We can turn on, for this one, the Microgrid demand app. Yeah. All right, so here I selected the Detroit. So once you select the Detroit feeder, here we want to input a load multiplier here, because remember, this is the feeder outage events. So it's just kind of slivers of load when outages actually occurred, right? And here we want to scale it to account for the fact that the load in this region is 50% of the feeder load, right? And we also want to scale it to account for what the load is going to be in year 10, which is our assumed kind of battery project life in this case. Detroit feeder outage events, right? And what you see here is kind of an outage occurrence, either 0 or 1, right? And here, kind of when an outage occurs, it's just there's load, right? But this is the feeder load here. Okay, so just very brief kind of Excel formula there. So, all right, the 67% we input here is to account for, the load in this region is 50% of the overall load of the system, of the feeder rather, and the 1.03 to the power 10 to account for 3% yearly load growth for 10 years. Okay, so that comes to 67%. So we input 67%. Right, then here, right, dispatch parameters, right? So here we're going to say, all right, discharge, right? We can do net demand or load. Doesn't make a difference. But discharge whenever, load is greater than 0, because for this case, we want to back up that entire kind of region, right? So let's say just discharge whenever there's a load. So we set this to 0. All right. Now, for charging, all right, this jumps up to the peak load shaving application. But here, right, for energy equalization, let's assume that, what did I have here? 1 to 6 a.m., we will do the same thing. We'll charge whatever energy was needed for the backup power application. So 1 to 6 a.m. and 85%. Okay, everyone good? Now, rather than running and then coming back and adding other use cases, right? We already know that there's a secondary application, right? Because when we described the scenario here, we knew we wanted to do reliability improvement, and we also knew we wanted to defer that substation upgrade, right? Or expansion, rather. So let's go on to fill the requirements of that secondary application. Oh, this is tertiary. Reliability. All right, here. All right, so we know the capacity rating of the transformer was 2 megawatts, right? So we turn on peak load shaving and we select Detroit feeder, this time without the outages. So this is the full feeder load. Input load multiplier 100%, because we're trying to shave the load on the feeder, so no need to kind of scale back. Now here, we assume the yearly load growth is 3% and planning year is 10, right? So it'll automatically take, 1.03 to the power 10 and base the calculations on that. Now, dispatch parameters, let's say it's based on the, 2 megawatt limit we set? Yep. Right. And the power ratio is 100%. Power ratio means when there's a difference between load and your threshold, what percent of that difference to discharge? All right. So now let's here kind of set the simulation to, this time it's 365 days, 15 minutes. So set simulation. Now let's see. All right, let's click run and see what happens. Okay, here, microgrid demand. So I said discharge based on load, and the discharge threshold, I set it to 0. So which means whenever there is load in the Detroit feeder outages file, address 100% of that. All right, click generate report, and we can look at the results here. BESS, not NWA. Cap specific. All right, so starting off with the peak load shaving application, right? The first chart you'll see here in the report is the energy and power needed. Now, this is the first application we're looking at over like 10 years, right? Because the amount of load that you would have at year 0 is different from what you would have at year 10. So it's telling you kind of for every year, how much was that energy that you needed. So here at year 10, we're finding we're at the kind of the 5 megawatt hour mark. And for power, about 900 kW. There we go. Showed up for me. All right. So that's for peak load shaving, which is based on non-wires alternative solution to defer upgrading the substation transformer, right? So now let's shift here. So here, this is the 24-hour profile for that function. So we can see we're mostly needing to shave that feeder peak between 10 a.m. to kind of the end of the day, right? So apparently, as expected, peak load doesn't occur during the night, right? And then here, this is saying really we're probably looking at June to July is when kind of these overloads are happening, or when the transformer capacity would be exceeded. So this shows the load without a battery, with the battery in green, and the discharge threshold here we set for peak load shaving. Right. We'll ignore this chart for now because we're not charging under the peak load shaving gap. We're using the energy equalization feature. All right, so let's shift to microgrid demand. So this is the reliability improvement case. So we're seeing here over a 24-hour period when we needed to discharge to provide backup power to that load concentration. So maximum was 1.1 megawatts and 3.3 megawatt hours we needed, right? And the events were scattered all over the year. So now I'll just kind of fast forward to the full profile. Now we set the microgrid, the energy equalization app to equalize from 1 a.m. I think to 6 a.m. So on a daily basis, like we said, whatever it needs for that day, it's charging for it. And let's start looking at the power histogram here. All right, so for sizing here, right, which side should we focus on? Charge or discharge? Right? Here, discharge, because we want to shave feeder peak, right? So we're going to be discharging from the battery to do that, right? And for charging, I mean, this period we set was somewhat arbitrary. We just said 1 a.m. to 6 a.m. It could have been 12 a.m. to 7 a.m., right? So here, from a sizing perspective, we start to get diminishing returns. So we talked about the power histogram. Now shifting to the energy histogram, and we talked about the blue part here. Now for the CDF, we see that we're really at kind of 90% at zero. That means more than 90% of the days you're just sitting there with a battery on idle, right? So even though with this battery, we're doing reliability improvement and we're planning to do get a non-wires alternative value by deferring upgrading the substation transformer, we're still using less than 10% of this battery system. So there's another 90% of value to be had, right? Okay. So how do we size kind of the system, or how do we set up this next application, right? We set it up based on the sizing of this one, right? Because it's, as we're calling it, a BESS capacity dependent use case, right? So for here, let's just kind of assume it's 1 megawatt, 4 megawatt hours. You can be more efficient, right? I mean, we just saw you really don't need more than 400 kW, but let's just assume we're going to size it at 1 megawatt hours, right? I'm sorry, 1 megawatt and 4 megawatt hours. All right. Okay, so let's assume we'll base the energy arbitrage application on 1 megawatt, 4 megawatt hours, right? Now, we know, like, let's assume for this region, for this utility, right,
winter peak is 6 to 10 a.m. and summer peak is 3 to 9 p.m. And this is actually Duke's kind of public peak. Now we can go back and then under the schedule app, right, add that schedule. All right. So here under schedule, right, let's set it to 500 kW. Charge, 500 kW. Discharge. And 6 to 10 and 8. I'm sorry. Well, no, for discharge, what was it? November to March.
Oh, was it November to March?
Right. Yeah, that's the winter peak was 6 to 10. All right, so I do 6. Where'd it go? All right, 6 a.m. to 10 a.m. And then I select November, December, January, February, and March. Then add. All right. And then for the summer months, right, we said what? April to October. What was it? 3 to 9. So it was 3 p.m. to 9 p.m. And then I select April, May. I could have just clicked all, but already halfway there. September and October. And then add. So for summer, I'm actually not going to do charge here, right?
At all the summer months.
Yep. So for summer, we're doing April to October. And for winter, April to October, 4 p.m. to 8 p.m. I actually said it wrong. And winter, 6 a.m. to 10 a.m. I'll just redo this one, right? So remove schedule 2, schedule 1, remove. All right. So let's start with winter, right? 6 a.m. to 10 a.m. So let's set this one to 6 a.m. and then to 10 a.m. Right? So that's 4 hours. And let's go here and we can select November, December, January, February, and March. And then click add. All right. And now for summer months. All right, summer months, let's say 4 to 8 p.m. or to 8 p.m. And now click all, right? Just click all and then add. So it'll pick all the remaining months in the year. And then add, and now you have your summer peak schedule and your winter peak schedule. Now run. So common question, why didn't we set charge? Well, we have energy equalization on anyway, so we know it'll charge whatever it needs for the schedule. The summer months is 4 to 8 p.m. And it's 8. You can just click all if you already loaded the winter months. All right, so for me now it ran. So I can just save this. Well, let me case 2 workshop, right? And I'll just save it. All right. So, okay. So this one, and now I need to, all right. Okay. So this is a report. It was produced. So we got the 3 use cases. First one's microgrid demand, doing the reliability improvement. Second one, peak load shaving, doing the non-wilds alternative, asset upgrade deferral. Third one is arbitrage. The tertiary application that is being performed 90% of the time, right? All right, so let's kind of go down here to the full profile analytics. Now we have something, right? This is something to be proud of, right? You got a battery system. In the beginning of the day, it's charging, right? For different reasons, either for schedule, for peak load shaving, or for reliability improvement. And then throughout the day, starting from 6 a.m., it's discharging for one or the other, right? So let's look at the power histogram here. So we can kind of very quickly notice the impacts of the schedule application, right? So here on the charge, we're at 500 kW. We're at more than 6,000 data points, right? And discharge at the same level. So that's the schedule application. All right. All right. Now the energy histogram, right? We can see now that, we're effectively utilizing our battery systems. Some days we're at the 1 megawatt hour usage mark. Other days we go up to 5 megawatt hours, but those are kind of limited, right? But really, when I look at this, we're kind of 90%, more than 90% of days is like 3 megawatt hours, right? Here for discharge. And for charge, let's see. Yeah, same thing, 3 megawatt hours, right? So when we get into the actual battery system design, which we actually, believe it or not, we have not started, right? We'll kind of look back at these and we'll kind of see, right, how, we'll see kind of the deficit. You'll see a lot of 95%, that we kind of predicted from the sizing here.